Now that we have calculated the declustering weights for the reference distribution definition, we have performed several estimations for validations such as nearest neighbor and inverse distance, and we also have our final estimated model of ordinary Kriging. We can move ahead and do some extra validations and model comparisons. For the extra validation and model comparisons, we are going to be using the class rmsp.ModelCompare. This class have many methods that facilitates the comparison of models and validation of models. So in our case, we are using a single grid, which is our grid that contains all our estimates. So this grid has the shell, the nearest neighbor estimate, inverse distance estimate, and ordinary Kriging estimate. We do not have a density model. So in this case, we're just using a single value that's going to be used for all the blocks. We are specifying the variables because we are only providing one grid to this class. We need to specify how we are comparing. So for instance, we can say that we are comparing gold, and the columns we want to compare are the nearest neighbor gold, inverse distance gold, and ordinary Kriging gold. And we could compare domains as well, but because we used the same domains for all the models, then we just repeat the domain column 3 times. So it's the same column for all the 3 models. And we can specify the model names. These names, they must match the order of the columns that we just specified. So the first column here was nearest neighbor. So this is the nearest neighbor model. Second column was inverse distance. So this is the inverse distance model. And the third column was ordinary Kriging. So this is the ordinary Kriging model. These are the required parameters for initializing a ModelCompare object. We can also specify parameters per variable. In this case, we are specifying the cutoffs for gold to be 1, 2, and 3 grams per ton or ppm. We're specifying the grade unit to be ppn, so it shows correctly in the plots. We're specifying a metal multiplier for gold to be 1 divided by a million. We are also specifying the metal unit to be tons of gold. We're specifying a tonnage divider to be 1000. So everything is divided by 1000 in terms of tons. We are specifying a tonnage suffix to be K, so that aligns with dividing by 1000. We are specifying a metal divider to be 1. We are already using a multiplier, so we don't need to specify the divider. And the metal suffix is going to be nothing because we're not dividing by anything. So those are all the variable parameters that we are specifying. So now let's see what ModelCompare can do. So to start, we use the ModelCompare class to build a CDF plot overlap for gold. So this CDF plot is just overlapping the distribution of gold in our models. So we see the ordinary Kriging curve in green, the inverse distance in orange, and the nearest neighbor in blue. So nearest neighbor is the most different distribution because it is very variable, high variance model. We're also adding the cutoffs to the plot as vertical lines. So we can see the cutoff at 1, 2, and 3. The last line in the cell is a statistics table for the gold variable. And it just shows the statistics for each one of the CDFs that we are looking at. It shows how many blocks we have estimated. It shows the mean, standard deviation, P10, P50, P90. We can see that as expected, the nearest neighbor has the highest variance, and inverse distance and ordinary kriging has lower variance. We can also use ModelCompare to compare the grade-tonnage curve. For that, we use ModelCompare.plot grade-tonnage curve, and we select a variable. Again, we should be actually doing this. So we are adding the vertical lines to the plots as well. So we can see the nearest neighbor in blue and the inverse distance and Krig models in orange and green. We can also quickly build Swath plots with ModelCompare. If we do ModelCompare.Swath and select a variable, we can select the directions for the Swath plot. In this case, we are looking to the x coordinate, y coordinate, and z coordinate. So these are the Swath plots for each one of the models. They are very similar. On top of CDFs, Grade-Tonnage Curve, Swath plots, we can also generate many different types of comparison tables. In this case, we are gonna generate a table that shows the tonnage, metal, and grade by cutoff for gold. And we are comparing the ordinary Kriging model to the nearest neighbor. And we are also comparing the ordinary Kriging model to the inverse distance model. So the two tables are shown below. So here we have all the tonnage, grade, and metal for the ordinary Kriging model. We have all the tonnage, grade, and metal for the nearest neighbor model. And we also have the differences, where the difference is calculated by dividing the ordinary Kriging model by the nearest neighbor. And we see the percentage difference. And the calculations are performed by cutoff. And we also have the overall values at the bottom. The same table is calculated to compare ordinary Kriging with the inverse distance results. You can see how this table could also be used if we were estimating a long-term model, a resource model. We could use this table to validate against the ore control model. So we could compare the long-term model with the ore control model in this kind of validation. These tables are generated globally, not by domain, but we can easily generate similar tables by domain by using the get tonnage metal grade table by category. And if we want to further split by cutoffs, we can also specify by cutoffs equals true. We can specify the categorical codes that we want to calculate for. In this case, we are defining all the codes and we're doing it for gold. So let's take a look at the result. So now we have a more detailed table comparing the ordinary Kriging to the inverse distance by cutoff and also by each one of the domains. And we have also the overall result for each one of the cutoffs. Note that this table doesn't necessarily need to be using the domains. It could be using any categorical code. So if you flag production volumes in your grid and you want to compare for each production volume, maybe for a given period of time, what was the production and validate against a ore control model, it's very similar call and it's super easy to build.